So section 1.6 for Algebra 2, we are going to look at absolute value equations and inequalities. Our focus today will be on the equations part of it. So our objective today is to write and solve absolute value equations. Okay? What do we mean when we say absolute value? What comes to mind? Distance from zero. What else? What kind of answers do we get when we take the absolute value of them? Positive ones. Yep. So when we talk about distance from zero, it doesn't matter if we're going in a negative direction or a positive direction. We still count how many spaces, how many units we are from zero. Okay? So absolute value is used to describe distance from zero. Our symbol for it are those bars, those straight bars. What do we mean when we say the absolute value of 4? What would we get? The absolute value of 4. It's 4. We're basically saying 4 is how many spaces from 0? It's 4 spaces. How about the absolute value of negative 4? It is also 4. So I put a positive 4 in, I got a positive 4 out. I put a negative 4 in, but I still got a positive 4 out. Yes? Now, the algebraic way of showing that for many students seems strange because we've just said my answer is always going to be positive, right? In symbols, the absolute value of x is x, just like we had here. The absolute value of 4 was 4, as long as x is greater than or equal to 0. So if I put a number like the absolute value of 0, what do I get? Sorry. Absolute value of 0 is 0. The absolute value of a positive number is the positive number. Yes? So the absolute value of x is just x, as long as we are at 0 or some kind of positive number. But what happened when we were taking the absolute value of a negative number? How did it become positive? What did we do? So we counted how many spaces it was from 0, which if we're dealing with a variable is harder, right? But we basically took its opposite. Instead of a negative 4, we wanted its opposite, which is positive 4. Another way to write that, the absolute value of negative 4 is just the opposite of negative 4. Does that make sense? So if my number is starting out as a negative value and I take its absolute value, I make it into its opposite. How we write that algebraically, the absolute value of x comes out as the opposite of x when x started out negative. Does that make sense? So I want you to think of this as opposite. The absolute value of x when x is negative is going to come out being its opposite. Okay? All right. Absolute value equations are ones where we have a variable inside of our absolute value bars. What numbers would make the equation below true? If I say the absolute value of something is 5, where can I be on a number line that I'm 5 spaces from 0? I could be at positive 5 or negative 5. So how many solutions would absolute value equations have? And that's the most common answer. Students say 2 because I just gave you an example where we had 2 answers. Does it have to have 2? If we take the absolute value of a positive number, we're going to get Sorry, I'm going to write that a different way. If I say the absolute value of something comes out as a positive number, you're going to tell me x could be two different values, right? The value of itself or its opposite. Okay, so this led to two solutions. Okay, what if I say the absolute value of x comes out to be 0? Now there's only one number that's going to make that work, right? What is it? 0. The absolute value of 0 is 0. So this leads to one solution. What if I say the absolute value of x comes out to be a negative number? It's not possible. We just said the absolute value is always going to come out as a positive value. So this one gives me no solutions. So I can actually solve an absolute value equation and have 0, 1, or 2 possible solutions. It depends on what this value, what it's set equal to. Okay? Questions on any of that? All right. So we are going to break out of jail. When I first started using this analogy, one of my students said, "You seem to know an awful lot about breaking out of jail. Have you been in jail?" I have not. So this is strictly an analogy. It's not based on actual experience. Okay? We are going to solve absolute value equations by breaking out of jail. We are going to picture those absolute value bars as the bars in our jail cell. Okay? We're trying to get rid of those bars. We want to get out from behind them. The first thing, it says, get rid of any guards. It's not very logical to say I'm going to break out of jail if there's a whole bunch of guards standing in front of your door. Right? So we're going to get rid of the guards. The guards are any numbers that are around our absolute value bars, but not inside them. Okay? So that's the first step. We want to get rid of any of those extra pieces that are outside. Our second step, when we break out of jail, it's a good idea to have two routes planned. All right? For two reasons. Number one, if we try one route and it's not working, we have a backup. Yes? Another option, if there's two of you in that jail cell, you can each go one direction and hopefully the guards will chase the other person. Okay? So, whenever you break out of jail, you're going to consider a positive route, a negative route. Okay? There's always going to be two routes. Once we have broken out of jail and we have these two escape routes or two equations that we're solving, from there on, it's just like all the other equations we've been solving. Okay? So the only thing new is we have to get rid of the guards and we have to draw our two escape routes. Okay, let's try one. So in this first example, are there any guards on our side? Remember, we're the x minus 8, right? We're inside jail. Are there any guards on the same side of that equation that are watching me? No. So step one's already done. The guards went to lunch. Okay? Step two, we need to break out of jail with two routes planned. X minus 8 is inside these absolute value bars. That means x minus 8, if we take its absolute value and we're supposed to get 6, x minus 8 could represent a 6, right? The absolute value of 6 is 6. But x minus 8 could also represent what? Negative 6. Because in either case, if this represents 6 or negative 6, the bars are going to turn it into 6. Does that make sense? Now, I always put the negative version here on the left and the positive version on the right. And I do that because tomorrow when we start putting inequality symbols in here, it's going to make more sense to have it set up that way. Okay? So just get in the habit. The negative one goes on the left side, just like on negatives are on the left on our number line. The positive version goes on the right. All right, how do we solve it from here? We have two different equations to solve. Notice we're out of jail, right? There are no bars. There's no absolute value bars anymore. As soon as you write two equations, you don't need the bars. Add 8 to this and we get 2. Add 8 over here and we get 14. So there are two values that would make that equation work. One is a 2 and one is a 14. We are not graphing an interval of numbers. We're not saying all the things in between 2 and 14 work. We're strictly saying that when x is 2 or x is 14, it works. Can we test that? If this was a test question, could we check that answer? Yes. And you check it by plugging it back in. Okay? If I put a 2 in there, 2 minus 8 is -6. The absolute value of -6 is 6. It works. If I put 14 in there, 14 minus 8 is 6. 6 absolute value is 6. Does that make sense? Okay. All right. Any guards on this next one? Okay, so we can just break out of jail right away. Remember, when we break out of jail, there's two routes, two equations. So 2x plus 5, we have two options for what it can equal. What are my two options? Good. All right. Subtracting 5. And divided by 2. Same thing on the other one. If we subtract 5 and divide. So we are saying that x could be -7 or x could be +2. Okay? All right. Our next two examples have guards. What are the guards in this first one? The 3 and the -1. Which one are we going to make go away first? Yes. We're going to get rid of that 1. It's a -1, so we have to do what? Add 1. We're going to add 1 to the other side. Now, absolute value bars are not the same as parentheses. We're not going to distribute that 3 inside. We're going to move it to the other side. Okay? I can add, can't I? 8 plus 1 is not 8. It is 9. All right. So now when we divide, what happens? We get a 3. So the absolute value of x plus 2 equals 3. Now we have gotten rid of all the guards. Now we can break out of jail. Okay? What's one of my escape routes? Good. Somebody else, what's the other escape route? X plus 2 equals 3. Subtracting 2, we get -5 or 1. All right. I'm going to pause the video for a minute. I want you guys to try the next one. And then check with your partners when you're done. All right, let's check our answer. So the first guard that I'm going to get rid of is the 3. I'm going to subtract it to the other side. Then I can get rid of this guard here that's 2, and I'm going to divide it over. Notice that I still am inside the jail, right? I haven't broken out yet. I've just gotten the guards out of there. So up until now, those absolute value bars still need to be around the x plus 9. Okay? When I split it into the two parts is when I am breaking out of jail. So the bars are gone. We have x plus 9 could be -2, or x plus 9 could be +2. Subtracting 9. and subtracting 9. We okay with that? So negative 11 and negative 7 are my possible answers. Okay. What happens if I say solve the equation, the absolute value of 3x plus 2 equals negative 5? Would you start looking at that and say, there's no guards, so I can write my two equations? No. Why not? Is there any way that what's inside that jail cell can come out as a negative 5? No. So right away we say there's no solution. It's amazing how many students start solving it and completely ignore that negative sign. Okay? It makes a big difference. Here there's just no solution. Can't do it. The other thing is that as we go through these, we won't always just have a number on the right-hand side. Like all of the examples we've done so far, it's always equal to set number, right? Look at our next couple examples. Now it equals another expression that has an x in it. That makes a big difference in how we go about solving these. We have to check for what's called extraneous solutions. Have you heard that term before? Extraneous solution? It's a solution that shows up because one of the steps we used to solve eliminated negative numbers. I'll give you an example. If you are trying to undo, say, the square root of x, how do you undo that? You square both sides, right? So if I have a negative number in here, when I square it, it turns into a positive number. So if you have a step in the question where all of a sudden you have to square both sides to simplify it, you've eliminated some possible negative things. Does that make sense? Okay. So there are steps we can do that change our final answers. Doesn't mean we did the steps incorrectly. It just means that the only way we could solve it somehow altered it, and we have to make sure that the answers we get are really working. So we are looking for what we call extraneous solutions or extra solutions. Okay? Are there any guards around my jail cell? No. So our next step would be to split it into the two parts. Be careful here. We are going to have 3x plus 2 equaling something on this side. We're going to have 3x plus 2 equaling something else. For one of them, usually it's the one I put on the right, we just keep the positive version, right? We haven't changed anything. So it's going to equal 4x plus 5. But what did we always do on the other side? We changed it to its opposite, right? Instead of a positive number, we made it into a negative number. So we need to do the opposite of 4x plus 5. Does that make sense? All right. So distributing that negative means the 4x becomes a negative 4x, the 5 becomes a negative 5. Everything is opposite of what it was. Okay. To solve this, I'm going to add 4x to the other side. Then I'm going to subtract 2. So I end up with x being negative 1. All right. On the other one, this time around, I'm going to subtract the 3x over. and then I'm going to subtract the 5 to the other side. So I have x being negative 3. All right, take a minute, talk that over with your partners. Does it make sense, the steps that I just did there? All right, the last thing that we have to do, we always have to check those answers, because remember I said we could create these extraneous ones? It is possible that both answers we get don't work. It's possible that they both do work, and it's possible that one works and one doesn't. So you have to check both of them, and that means plugging them back into the original question wherever there was an x. So when I check this negative 1, I'm plugging negative 1 in for the x and seeing what I get. On the left side, 3 times negative 1 is negative 3, plus 2 is negative 1. The absolute value of negative 1 is 1. So this whole side simplified down to be a 1. On the other side, 4 times negative 1 is negative 4, plus 5 is 1. Both sides gave me a 1. They match, then it works. So this is a solution to that question. When I check the negative 3, plugging it in, three times negative 3 is negative 9, plus the 2 is negative 7. Absolute value is 7. On this side, 4 times negative 3 is negative 12, plus 5 is negative 7. 7 does not equal negative 7. This one is extraneous. So what I want you to do on your homework, on a test, I want you to cross this one out, not scribbling it so I can't see what it was, but put a line through it, write extraneous or just ext next to it that tells me you checked it, it doesn't work, but I can see the process you went through. Okay. Let's go ahead and do this last one here. So variables on both sides. No guards. 5x minus 2 has to have 2 escape routes. The one route on the right-hand side is going to be the positive or exact version that I had here, the 7x plus 14. On the left side, what do I have to do? What do I have to do? Okay, we're going to make it be its opposite, so we're going to put a negative sign in there. So the 7x is going to become negative. The 14 is going to become negative. Right? It's all opposite of what it was. All right. I want you to go ahead and try to solve both of these equations. I am going to work through it up here. Okay? But try to do it on your own and then just check your answers. So where you really have to be checking your answers and looking for those extraneous ones are the ones where you have variables on both sides. Okay, if your absolute value is equal to just a constant, no variable, then you're fine. All right, assuming you did all the steps correctly, they should work. But when you have variables on both sides, you definitely have to be checking those. All right, so for homework tonight, you are going to do page 46, 10 through 24 even, and 43 to 51 odd.